Hey guys, what's cracking? Hope everybody's doing good. I'm gonna go ahead and do a stream here. I tried to do one this morning in case you guys didn't know. My computer completely jacked me all up, so I ended up not doing it. But lucky enough, there were a lot of people doing videos on the earthquake anyway, which is why I was coming on so early in the morning. So that got covered really well by a lot of different people. And I'm not the earthquake guy anyway, but I do bring that to you guys when stuff like that happens. It was a pretty decent sized one, but is what it is. So, what are we gonna do here? Well, we're gonna talk about space weather too, because we do actually have some space weather. Stuff has definitely picked up, and it's kind of what we've been talking about here for I don't know, but about 4 or 5 days. I kind of started mentioning it, and it's from sunspot, right? And the sunspot grouping I was talking about a few days back that had crested the limb, and we'll just take a look at it here real quick, right here. This sunspot group. Now, let me. I tried to go to the SDO site, which is what this is from GOES, I think. I'm not sure where this one's. I think this is GOES satellite, but SDO gives us the same kind of view. It's usually the one I show you guys all the time, right? If I go over here to ISWA, let's go to, that's seeds. Here's ISWA. Okay. I want to see if this is SDO. This is the one I show you guys, constantly. I'm not sure that it's updating. And because I went to their site, the SDO site, and it was jumping all over the place. Like it was really missing a lot of data. So we're going to take a look at that and see if maybe, let's see what the date is here once this thing loads real quick. Okay, well, it might be. Might or might not be. Let's see how far it takes us. To the 12th. Okay, well, it's working. So that's a good thing. So we'll take a look at this here in just a few minutes. Well, actually, I'll tell you what, since that booted up, what we'll do is we will do this. Let's do, I think it's the solar continuum here. It's the one I want, I believe. I hope it is. We're going to find out. But while that's loading, we're going to go ahead and go back here and move forward with the show here. I don't want to waste your guys' time. But we've had quite a few M-class flares. Okay? Right here. Each time these things bust up to M-class level, that means that you're going to be looking at probably a low-level geomagnetic storm. Okay? Not geomagnetic storm. I'm sorry. A low-level radio blackout storm conditions. Okay? So, an M1 would be like an R1 radio blackout, and that's all forecasted over here at NOAA. And so let me show you where that's at. You come over here to NOAA, Space Weather Prediction Center. You're going to see all this stuff up here. This is geomagnetic storm stuff here at the top. Okay, for the 12th, 13th, and 14th. What they're doing here, these numbers are the KP index. The KP is what we look at for geomagnetic storms down here. KP of 5 is a G1 storm. And, and it goes incrementally up, and so do the storm conditions also. Now, you can scroll down, you look at S1. Those are solar radiation storms. Okay, that's a proton blast. Now, they're saying a 10% chance. Now, that's actually, it's a little bit more, it's a little bit more than just off the bottom of the floor here. And usually we're sitting right around 0 or 1% this thing reads. So there is an increased chance. And why is that? Well, it is because of these flares in the sunspot group. Okay? And as we look here, this down here is your radio blackout conditions and what they're forecasting. So when you see it say R1 to R2, what that computes to is an M-class flare. Okay? If it gets into R3, you're talking an X1. That's how these work. Okay? So right now you can basically say this. There's a 25% chance of an M-class flare the 12th, 13th, and 14th. the whole range of M class, right? There's a 10% chance of X class flares. Now again, most of that usually stays right around 1%. Now we're moving towards solar maximum, so those conditions will hang around a little bit more. You'll see them more often, I should say. But that's what this is trying to show us right here, the 10% and the 25%. So I encourage everybody to go over here to NOAA Space Weather Prediction Center and check it out. And anytime that there are any kind of storm conditions at all, they're going to light these boxes up. Okay, this is a 24-hour observed maximum. So in the last 24 hours, the biggest radio blackout that we experienced was an R1, which is low level. Okay, but it still did happen. And you could go, and when you see these things pop off, it's not necessarily saying, oh my gosh, we had this radio blackout. It's saying that the conditions are there for that to happen. So you have to go around, you have to go look at your news feeds and all those kinds of things. And you can start seeing where they start reporting radio blackouts. And we're talking mainly like ham radio operators. First responders use that communication, that type of communication, that technology. So let's oh, and before I move forward here, I don't know what happened over on at the end of the show there on Mark Fugal. I'm not sure if he got it back up or not. But his stream just just stopped, and everybody kind of went bloop. Everybody, his stream went down. I think it was on his end somewhere. I'm not sure if he lost his power for a minute or maybe his internet. But D-Live went down. YouTube went down. It all went down on his end. So something happened most likely where he's at. That's just my assumption. I don't know that for sure. But that's what happened right there just a few minutes ago. And I did come over here and look and see if we had a flare or something hit, and we didn't, like right at that moment. So, but anyway, so R1 conditions, that's what we got with all these flares here. Now we're going to go take a look at these flares, okay? I will show them to you here in just a second. And I think somebody was asking me about LASCO C2 or C3 here, the blue view. I'm not sure who asked me that. I think I seen it in the chat there. I can show it to you here real quick. This isn't going to show you much, but you're going to see it. All this is a zoomed out version of LASCO C2. This is C3, and that's C2. Okay, and there was a couple of eruptions with the flares, so there were some CMEs. One of them, which is coming right at us, at least it looks to be. It doesn't look to be like extremely strong, but you guys remember, it doesn't have to be if it's going to be hitting you right dead on. And this one is, at least according to the model. Okay, right here is the model, and you're going to see it. Right here is Earth. I mean, I don't know that I've ever seen one hit more direct. It really did hit. It's going to hit us right in. I mean, it's like we're going to take this one on the chin. It looks like. Now it doesn't look to be very strong. Okay. But again, well, it does kind of look like it might be sailing a little south of us here. It might even kind of fade off there too. So maybe we're not taking this one so much on the chin like I thought after looking at that again. Let me go ahead and zoom in here a little bit, and I'll show you what I'm talking about. This is a top-down view here on the left. Earth's the yellow ball. Obviously, that's the sun. Now, if you just looked at this one, you would think that this thing is just going to hit us right in the middle, right? It's a top-down view. The side cut, you can see where it looks like it might be sailing a little bit to the south, which could be what it's doing. And we'll take a look at it here in a minute. And most likely, it probably is. Looking at this model here. But this here is our orbital line around the sun, stretched out in a straight line. So we got three different axes we can look at here. And it gives us three different perspectives so we can get a good idea of the direction that the CME is moving. And, it shows it hitting us here, or at least giving us some sort of a glancing blow. Here also, not so direct, but still kind of glancing. And then you'll see the distortion here, like that. It does look like it's going to hit us. So, if it hits us right on the chin, who knows? If not, it won't be such a hard hit. But, again, it doesn't look to be very strong anyway, but when we got geomagnetism already hanging around, and we really don't right now, just to be honest with you on that one, because, let me show you. we've been in the basement here. Like the whole day on the 10th, we were like really, really low geomagnetic activity. And what that does is that opens us up to cosmic ray exposure. Now, nothing really bad is happening there. We would have to stay like really, really low conditions for a good amount of time for it to really affect us here on the surface, at least in a big way. But as you can tell, it started to pick up, and what that means is some, either from small coronal holes, CMEs, it's plasma interacting with our magnetic field here, and that's what's giving us this geomagnetic activity, and that's what raises these levels up. Okay. Where's our chin? Well, it depends on what mirror I'm looking in, because, I got like 12 of them, 12 chins. No, I'm just kidding. But no, yeah. When I say the chin, I'm talking about just like hitting it straight on, like all directions, like just a big direct hit. But again, that one didn't really look like it was going to do that now. So let's leave that at that. So let's go back over here to ISIL real quick, because I want to show you the sunspot here. I have to, man, that thing did not update. I forgot I had to do that. Let's take it here. Let me update this stupid thing. We'll go back and look at something else while we're waiting. I'll tell you what we'll do. Let's go ahead and go over here to, now this, guys, this is the HP. Again, that's a 30-minute data plot. This here is giving us the same data as what we see here, but these are 3-hour plots, okay? This is a 30-minute, so, not a whole lot's been going on. And you can see here from the 11th all the way through the 10th where we were really, really low. So, and we were low back here too, but then we, I think we caught a geomagnetic storm right here, a very short-lived one. Wasn't that big of a deal at all, but it did happen. So let's go over here to the Discover data. Okay, this is space weather conditions, basically. What we're looking at here, guys, in the orange is density. So what we look for there is 4 centimeters cubed was what we consider normal. Anything above or below that is what it is, right? So we're hanging right around 10. Now, again, when we're talking about density, guys, I've seen the thing get up to 20 or 30 and not really give us a hit at all. And I've also seen it down as low as 1 or 2, and because the solar wind speed was high, we took a hit at that low density level even. So I hold stock in the density because it does matter, but you can't just look at density by itself, and you can't just look at speed by itself. That's why you have to look at all of it, okay? Because on their own, typically they can't do a whole lot. But if both of them are reacting and moving certain directions or what have you, yeah, we've definitely got to pay attention when they're both moving, right? Now, when we look up here, we're looking at the BZ. And what we're looking at there is that's the angle of our magnetic field. Basically, I'm not going to get into too much detail there, but we look for -6 or bigger. That's really pretty much what we need to look for, and frankly need to know as far as if we're going to be taking, if we're opened up enough to take a pretty good hit, to let the stuff come in fairly easy, and which allows us to take bigger hits geomagnetically. Okay, so we know that things come in easier on our poles. So when we get tilted certain directions, our magnetic field gets in certain positions. It allows things to open up, and I'm using that word "open" very loosely there. Okay, it allows things just to let things in a lot easier. I'll just leave it at that without going into too much word salad. You got -6 or bigger, like I said a minute ago. So when we look at this and we see it say -6 over here on Discover, they'll shade this out in like a purple color. Okay, so whenever it's in that color, we are in a position to where if we're going to be getting hit with any kind of space weather, it would come in fairly easily, and it typically will give us a higher level storm condition, okay, or just a higher level geomagnetic condition altogether. Okay, doesn't necessarily have to be a stormy. Okay, We get geomagnetism outside of storms all the time, right? It's here all the time. So we have to keep that in mind. It doesn't necessarily have to be in storm conditions for that to be taking effect up here. Okay, but the speed here, guys, 3 to 500 is what we consider normal kilometers per second. It's not even breaking 500. So everything's kind of in normal range right now, and that's exactly what I would expect to see, you know, coming over here and seeing this. Nothing's really out of the ordinary. And actually, right here, that's kind of where we want to be. We want to be right there at about that balance point. Okay? That balance point allows us to block cosmic rays pretty decent. Anything else coming in from space, those kinds of things. It helps us block stuff, right? The sun actually helps protect us from the sun. If we got a certain amount of geomagnetism hanging around and we get a big CME blasted at us, what happens? Well, we're able to kind of, you know, brush it off a little bit. It does help that we had a little bit of this stuff hanging around. But also, if you got it hanging around, you take a big CME, it makes things worse, usually. Okay. Sorry, man. My mouth was dry there a little bit. Sorry, I had to take a drink of my my coffee. So let's take a look at. Let's go back over here and see if this thing is loaded yet. Okay, it has. So I started showing you guys these sunspots a few days back, right? So if I go forward here with it, that's right in front of us, and it was flaring. It started flaring about right here. And if you guys remember, I was telling you guys that this thing was in a pretty stable condition, even though it was big, right? And it is. You can see when the reds and yellows are that far apart from one another, typically that's the polarity, okay? That's what you're looking at there. That means it's pretty stable. So what we look for is when we start getting smaller little spots inside that are different polarity next to one another, that's when the thing starts to flare. And that's exactly what happened. Okay, so see how we started getting these little red spots? And they're getting real close over here to the blue? And so watch what happens. As I come closer here, you see that? That's actually pretty significant, because when that one did pop off, I do think that that's a lot of the reason why we're getting flares right now. It's close enough. It is starting to, you know, and it's holding enough energy to give us X-class flares. So if this thing wanted to, it could blow an X-class flare right now. And if it did so, it's facing right at us, so it would be coming at our direction if that happened. I'm not saying that's going to happen, because, you know, even going off of their forecasting, they're saying, you know, like a 10% chance of that. Yeah, that's a little bit higher than what we would consider normal conditions, but it's still not that high, guys. Let's keep it in perspective when we're talking about that. So, you know, I don't want to over-exaggerate things. And so just keep in mind that definitely is, it's a little bit of an uptick, but it's not nothing to be like, oh my gosh, what's going on? I've seen that thing say 30 or 40% before. So, but yeah, so you see these little red polarity signatures here. And when they're getting that close to the blue, they start intermingling, they start flaring, and that's exactly what we've seen. Okay, this is another spot up here too. So as these things come closer together, we can look for more instability, all that stuff. But for now, you know, we're getting flares. So let's change the type here. Let's go ahead and look at the, oh, I don't know, the 131. How about that? Okay, we'll let the 131 load there. While that's doing that, I can take you over here to seeds and show you some of these eruptions that's happening. Okay, now this is on the 11th. This is today. Well, depends on where you're at. I guess, is it midnight yet? I haven't even looked. Probably is. Yeah, it's 12:30 on the Eastern time zone. So as you can see here, guys, you're seeing some eruptions. Now remember, this satellite's about 1 million miles closer to the sun than what we are, and it's always looking at the sun. So it's from our perspective. Also remember, this black disc is an actual disc on the camera. It's a physical thing. and it blocks out the main light of the sun, so we can get any kind of capture at all on these coronagraphs. So what do we look for? Well, we look for what we call a halo signature, okay? And what that is you'll see it's exactly what you think it is. You'll start seeing a little haze around the whole occulter disc. That's what that thing's called. It's called the occulter disc. And when you start seeing that little bit of haze, what that means is that there's been a CME either coming right at us or going away from us, because we can't see behind this disc, right? So let me pause it and I'll show you what I'm talking about. Okay, so do you see how it's kind of hazy right here? You guys see that? What's going on in a 15-second snapshot? Well, we've got some CMEs happening and some other things going on. So I had some flares. Nothing like gonna be doing crazy stuff as I can see. But anyway, you see this little bit of a haze. So let me go ahead and I can just take this screen by screen. All right. So that's kind of what we call a partial halo. So we don't know if it's coming right at us or if it's going off the back. Julie had a question. Okay, hold on. I will stop and answer questions, guys, because that's what I do. I'm not a squirrel in here. I'm actually answering some questions. If I can get back up here to Julie. Okay. Makes a big difference if grid goes down because a direct hit on grid, or did they put the grid down deliberately to preserve the hardware? Okay, now listen. There, you guys can read that. I guess I could read it again. Let's see here. Julie Watson's asking a question here. Ask him about makes a big difference if grid goes down because of direct hit on grid, or did they put the grid down deliberately to preserve the hardware? Okay, there's some misconceptions when we're talking about the grid. Okay, and this is very common, because I had to actually, like I said, when I first started looking at this stuff myself, you have to really dive into that to really understand what I'm getting ready to say. It's better for them to leave it on. Okay, and I'm not going to get into a whole lot of detail here, but because it would take quite a long time to explain that all the way through. All right, but what I'm saying is, if they seen a CME coming that was just huge, and they went over and started shutting things down right away, right? Well, I guess at a basic level, and I'll just say it like this. If you've got, because we're talking about electricity at this point, okay? And just like magnetism, electricity has a positive and a negative. So if we've got stuff moving through our lines and through our grid system, when something hits it, it's able to, just like geomagnetism hangs around in our atmosphere, it's able for us to kind of fend it off a little bit better. Now, that is a very basic, it's so bottom floor basic, it's hard for me to even say it like that. It's actually fairly complicated to be able to explain that all the way out. Okay? If you guys wanted to go look and try to figure it out yourself, you can Google that. Actually, Tam the Scope actually talks about that. If you guys want to go over to her channel and check her out, she talks about why it's better for the power to be on during those events, because it will help actually kind of it won't be as bad. Okay. And I really can't go too much more into explanation on that, because it would really take us down a hole that we would be here for a long time doing. Okay. But that is a great question. Thank you for asking that. That's a very well thought out question. It really truly is. I don't know that anybody's ever asked me that question. I know that I've heard other people ask that question before, but nobody's ever asked me. It's not something I usually try to go into because it does take a minute. So thank you, Julie, for asking that. That's a big question. And it's a very legit question to have. So, yeah, I love those kinds of questions. you know, and I'll just be straight up. I don't know all the science behind that either. Okay, so I'm not going to sit here and pretend that I do. I am just not going to go there. You know what I mean? You guys want to go into it and dive into all that in a really deep scientific dive, you can. All that information's out there, and like I said, there's a lot of people out there that, I won't say a lot, but there are some videos out there that will explain it rather well. Now, I did watch Tim with the Scope explain some of that, and a couple other people, and I did understand it. Now, can I explain it the way that they did? Absolutely not. I cannot. Hey, good night, Aliyah. Thanks for stopping by. Appreciate you. Thank you. So, what was that I seen there? Seriously, question, not joking. Did we really land? Okay. You know, I don't usually go into those kinds of questions, Kool-Aid. And the reason why is just because it leads down to nothing more than, you know, even if me and you weren't going to argue about it, somebody else would argue with me about it, whatever my opinion was on that. And at the end of the day, it would just be my opinion. So I don't usually talk about that because it won't do me any good. You know, I'm just trying to show you guys space weather conditions and what the sun's doing. It's kind of what I do. No, I'm not saying that ain't a legitimate question. Okay, 'cause don't get me wrong, because I most certainly think it is definitely a legitimate question. Okay, I don't think you're trying to cause an argument either. I'm just wanting you to know that's why I'm not going to get deep into that. You know, because there's there's stuff on both sides, you know, and usually when one side is saying one thing, the other side's saying the other, and and just like anything else in this world today, nobody ever wants to come to the middle. And it's sad. It really is. It truly is. It's sad. But yeah. Yes, you need to do that, Julie, please. Go back and I believe she's got some playlists back there. Okay. When was the last great CME? 1859 Canadian? Nope. Guys, we've had big ones since then. Okay. 1989. The Canadian grid, part of the Canadian grid went down. Okay. But yeah. Oh, I got a PayPal link down there, Kool-Aid, but I wouldn't worry about it. It's not a big deal. That's not what I do here. It's okay though. I appreciate you. I really do. But yeah, that's in the description box. I don't monetize my channel, so. But yeah, I never even mention that usually. Nobody hardly ever asks me that. So, but because they already know usually. But has it arrived yet? No, it's not here yet. But to answer the big CME question, no, there's been a lot since then. You know, it may affect us. The flare part is not geomagnetism. The flare part of it is actually X-ray. So yeah, the X-ray gets here in 8 minutes. There's absolutely no warning for those kinds of things. But so let's go back here. Aurora, I'm not even going to show you that because that happens when we're getting hit with stuff, and we're not at the moment. This geoelectric field, not much going on there either because, again, we're not. So, here's that CME from the flares, and we're going to take a look at the flares here in just a second. I was waiting for them to load. So this is the 131 angstrom. Okay, hopefully daggone it did the same thing to me. Okay, we'll go back here. What I do want to do here, guys, I'm going to show you stereo A. Okay, stereo A is a partial side view. Okay, so if we look at stereo A, it's going to give you a little bit better idea of the direction of what things are happening. Earth would be over here. Okay, so you can see here on the end that this explosion or this eruption does look like it's coming at least roughly our direction, right? And so if we go look at a different perspective, like from looking at it directly on, you could definitely see that it's being hid by this occulter disk. And so how do we know if it's coming at us or going to off the backside? Well, I just showed you how. Okay? Because right now, anything behind here, we don't know if it's coming at us or going directly away from us. So what do we have to do? We have to go try to look from the side. And that's what I just did here with stereo A with you. You can see how it's coming this way and not going off the backside. Okay? There is a couple eruptions here going off the backside, but those are small, very, very, very small ones actually. But you can see here, and we'll keep an eye on it. We'll see what happens here. So if we go back to here, all right, this is the 131 angstrom. You're going to see this thing start to flare. I'm just going to grab it here. Watch right here. You'll start seeing a bunch of flashes. That's the first one. See it? This is just flashing constantly here. What the? That's weird. What in the world? You guys see that? Am I seeing things here? Okay, now I'm gonna have to look at this for a second, so please hang in there with me here, okay? I looked at this earlier, but I didn't see it do that. And you probably like, what are you talking about, Wages? Just tell us, right? Well, let me show you what I'm talking about. Okay, so here's that sunspot I was just showing you guys on the other view. So let me go forward here, and it is erupting. See that? It erupts out. But check this out. Watch this energy come from here and get sucked back to the sunspot here. See that? You would think, guys, look. I want you guys to watch this. So watch what happens here. See how they erupted out? What's different? I'm going backwards. That shouldn't be doing that. So that's forward. I'm moving, that's backwards and it's moving away. That's forward and it's moving towards. What in the world's happening there? I have no idea. I don't. So, and most likely it probably came down from here and we had a magnetic connection line from a filament probably. So it's not something that's crazy weird or anything, all right? It's just we don't typically get a view like that. So you got plasma traveling on these magnetic connection lines, guys. So when they do, the charged gas, which is plasma, travels on those lines. So, and yeah, so when I seen that, it was just really odd. I just had never, well, I hadn't seen that in a while, okay? Now, right there is the biggest flare. One thing I want to say, again, I'm moving backwards there. You can still see plasma kind of flowing out here. But that's moving full, that's backwards. Okay, watch right here. I'm going to go forward, but all that plasma is going back towards the sunspot. See that? Now, that does happen. All right? We've seen that happen so many times on the 304 view, which is the ionized helium. And matter of fact, let's just go to that. I'll probably have to update the stupid thing like I did a second ago. Let me take this thing. It's almost done with the original update there. Hold on one second here, and we'll get it going. We can look at the 304. We see solar rain a lot on this one. Solar rain and solar vortexes. It shows it really well. Take this thing all the way to the end. And with the sun being the background, okay, we don't see things very easily. So when things happen here on the edge, we get the benefit of having space as the background. So I'm going to refresh that, and we'll let that thing load. And you can see here what some of the stuff is already doing. I've shown you guys this 1,000 times before with the solar rain. coming back to the surface. So yeah, man. So let me go back to here. All right, good. It loaded. Sweet. So let me pause it, and I'll grab the slide bar. That way I can control what we're looking at here. I'll be able to show you better. Okay. So here's that sunspot grouping again. Heck on it. Why did it do that? All right. Hold on. Okay. So that's exactly what happened. Okay. And let me show you what I'm talking about here. Okay, so this thing's flaring, right? So we're moving forward right now. Now watch what happens down here. You see that? Watch right here. Okay? And it even did it there on the end again. This filament is connected to that sunspot. There's a magnetic connection line there. Okay? So, and I know it's hard to see because the sun's the background. These are hard things to see when the sun's like that. Okay? From this position. But, you know, to see that, for somebody that has never looked at this stuff before, would think that is just so crazy. Because if you move forward, you wouldn't think you would see things going into the sun, right? Well, it's really not. Okay, so I'm moving backwards there, and that's moving out. See? So if I go forward, watch what happens. See it right there? See how it kind of erupted right there a little bit? Not really an eruption, but what happened here is the plasma went. It connected, and it went from here to here. That filament probably lifted off a little bit. At least that's what it looks like. And you can even see how this is kind of getting pulled this direction down here. So it's got a pretty strong connection down here with this filament laying across there. Okay? See how bright that is? So that does look to be what's going on. These lines are filament lines. Those are magnetic connection lines. That's how the plasma moves. So, yeah. And did you see that? Look there on the end. Watch what happens here. Wow. Okay, so see that's substantial. Watch what happens. It starts to erupt. It's going to go down here and it's going to take a turn. Watch. See that? Look. That's a lot of plasma getting ejected off. Now, it does look like it's getting ejected kind of to our south, so maybe that's why the models are showing that. So, you know, and again, once we get more stuff coming in, I'll let you guys see it, and I'll be back on the report. But as you can see, we got the blackness of space back here. Now watch this solar ring. This is what we call solar ring. You see it moving back? You can see it moving, and you can see the magnetic connection lines. It's just really visible. Okay. Now, something else too, we've been having a lot of sun divers. Now, I'm not saying that there was a sun diver there, but sun diving comets can actually instigate eruptions on the sun. Most of the sun diving comets never make it to the surface, but some of them have enough disruption, enough magnetism to cause the sun to do certain things. Okay? And that's what happens. So, yeah. I'm sorry I'm here right now at this time. I don't like streaming right now, especially on like a Saturday or a Friday night, because it just doesn't. Yeah, people are just they're living their life like they should be. But yeah, so there's that. Now let's take a look at the earthquake reports here real quick. Again, guys, pay attention to this, okay? Because space weather does affect this. That's why I talk about it. Now, I'm not going to go into details or try to tell you guys a bunch of certain technical stuff here on this, because I'm not the earthquake guy. I'm just here to report that it's here. This is what's happening, and I can tell you that they know that space weather affects this. Now, at what level, they're still trying to figure that out, and they're trying to use it as forecasting. That's why we look at this particular tool. Okay, that's why USGS has its stamp here with NOAA at the same time. So they're working together here, trying to bridge that gap to put together some good data and to get some good models out there to forecast, hopefully help forecast upcoming earthquakes. Now I have to say this too. All you had to do is look around YouTube the past week or two, and you would have seen everybody that reports on earthquakes start talking about the past week and the next week going forward here. They've been saying it for a while. Hey, we're going to have some earthquakes, guys. Pay attention. Now, it's not just about solar weather, though, okay? There's so many other things involved here, which I don't understand well enough to even try to attempt to teach you guys that, or to even spread it on with any kind of confidence, okay? So I'm not even going to attempt that. I would be doing you a disservice, and I wouldn't be doing the right thing. I know my limitations, and that's what it is, you know? Hey, Heather, how you doing? But what I can tell you is space weather does affect us. Can you explain the significance of different colors of aurora? No, I mean, that's a good question. It's actually fairly quick, Tad. Thank you for asking that. We can go over here to the aurora model. I tell you what, I'll just run these models as I'm talking to you guys about it. This is NOAA's forecasting models. And what they do is, yeah, Ashley, a little crazy stuff, but it's not too bad. And remember, never fear anything, guys. There's absolutely no fear here. We don't do that here. So, but anyway, thank you, Conspiracy Realist Mom. I appreciate you. As far as aurora colors, now there's a lot of different things that we could talk about here, but when you see the colors from the aurora, what you're seeing is the excited atoms trying to go back to their stable state. So when you got oxygen molecules and you got nitrogen molecules, those are the two main ones everybody talks about. Okay, now oxygen molecules usually, well, they're hanging out higher up in our atmosphere than what nitrogen is. Okay, so when an oxygen molecule gets excited by space weather, by plasma, by solar wind, CMEs, those types of things, it excites these molecules, and they're trying to go back to their stable state. In that process of going from that excited state to the stable, back to the stable state, it puts off that glow. Okay, so oxygen typically will give you green. Okay, now nitrogen is going to give you a different color. Nitrogen is going to give you reds and pinks and stuff like that. Now we're talking about in general. Okay, I'm not going to go into detail what all these colors and all that stuff is. So why does it matter? Why is Tab asking that? Well, the reason why, and I believe this is why she's asking it, is because it is significant to know that nitrogen's lower. So what does that mean? That means that the space weather has penetrated more, and it is down lower, closer to the surface, and it's excited molecules down that low. So typically that means we're getting hit harder, or there was a crack that opened up in our magnetic field and was letting stuff in. There's a whole lot of different scenarios that could be the case there. But essentially, it's all about the elevation of where the molecules are hanging out in our atmosphere. Okay? So that's what's happening. So when they get excited and we see reds and stuff like that, those are nitrogen. Those are usually lower. That will typically mean that we're getting a heavier hit from space weather. Eat pink also too, Charles. Yes. Yes, it's yeah, 100%. You get pinks and reds, and believe it or not, oxygen I think can produce red ones too. But there's a whole lot of science here, guys. It's way too much to try to like compact in. But again, just kind of remember that. Now that's it. That's a general rule of thumb. It doesn't necessarily mean that happens like that every time. So keep that in mind. But it's a very legitimate question, Tab, because it's significant, because it's something we can look at to say, hey, yes, we're getting hit pretty decent here, and here's some of the proof of it. So, yeah. So, anyway, that's a great question. Great question. But that would be like I guess the quick answer for everybody. Yeah, purple rain, love it, love it, love it, love it. We do see purples, guys, and there's other phenomenon that happen too, like sprites and eddies, things like that. And I'm not going to go into what all those are, but yeah. So, great questions tonight, guys. I appreciate you. I really do. Thank you for asking those. I don't shy away from questions. I try to answer them if I know the answer to them. And if I don't know the answer, guess what I'm going to do? I'm going to tell you, hey, I don't know the answer to that. I'll try to find it. If not, here's somebody to go look at, right? What I do earlier with Tam with the Scove. I mean, yeah. So that's what I do, right? I'm not going to come out here and just blow a bunch of smoke. It's just not what I do. So. All tight area where Ohio. Oh, you talking about earthquakes, Julie? Right here? Yeah, I seen those earlier. When they popped off earlier here. That was on the 11th. Really, almost 24 hours ago. And that one also. So both of those. Now there's probably some smaller ones there too. But anyway, guys, yeah, this was the biggest. Obviously, that's the big deal right now. Would be the one over here off the coast of Tonga. Now, I think there was some small tsunamis with that, just small little waves. But yeah. Oh, you're welcome, Charles. One thing I do want to show you that I didn't show you, I can show you real quick. Whenever I look at like the earthquake stuff, guys, and I see this box, right? We could click on that box, which I'll do that real quick. Okay, so this is what NOAA's going to tell you. No tsunami warnings and all that stuff, right? It's a really good, quick thing to look at to see if there's a tsunami or anything, any kind of warnings going out. But you can take it the next step, okay? So what do? Well, you go to the National Buoy Data Center. Okay, right here. And what these are tsunami buoys. That's what they're there for, right? They're going to be trying to pick up whether or not, we got wave discrepancies. In other words, water going up and down because of earthquakes. Okay? So there you go, right there. When you come over here, the ones that are in yellow, you guys can go read the key down here. Stations with recent data are yellow. Stations with historical data only are orange, which I don't see a whole lot of those. Stations with no data in the last 8 hours are red. In other words, they're not working. Okay? They've been shut off, might be doing maintenance on them, something. But when you catch a yellow one that's blinking like that, okay, which is what we got here, that means that buoy is in event mode. Now, I just showed you guys where the earthquake was. So where it makes perfect sense that this buoy would be going off, right? So what you see, you click on that and it'll take you here, and you can see right here where it's trying to show you where the discrepancy was at. Okay, you got 15-minute sections here with the blue lines, then you got 15-second sections with the red, 1 minute with the green line. Okay, so you can click on View Event Details and you can start looking at these graphs. You start looking at wave heights. Okay, so that's what that's trying to show you. Now you can go dig deep into this. Thank you, Tab, for putting that link in there. I was getting ready to do that. Thank you. Guys, if you guys want to come to this, come over here and check it out. I encourage everybody, please go check out everything I just showed you guys. How do you get to everything I just showed you? Let me show you. Come over here, and I'll put this in the chat also. Yeah, I think it's in my description box also. So anyway, put it here. All right. So if you come over here to the NOAA Space Weather Prediction Center, you scroll all the way down to the bottom. Here's almost every link I show you guys. Every tool that I showed you tonight, you can pretty much get to from down here. Okay, everybody can access this. Why? Because our tax dollars paid for it. That's why. Now, I know everybody has issues on what they believe and what they don't believe, and that's for you guys to decide for yourself. But for me right here, this is where I go to get the tools. And there are a few different sites I go to that don't have nothing to do with this. Like this one. This is a German site, okay? Again, I saw this over on Tamantha Scove's channel. She was showing us this because it's more real time. So you get a data collection point here every 30 minutes instead of what you get over here, which is every 3 hours. So you can see how that could benefit, and you could get a better idea of what's actually happening. So well, I would love that. Louisa James, that would be cool. I really do try to just like bring it down. Yeah, spaceweather.com also, Anna. Yeah, you bring up a good point there. Let me take you guys there too. I usually show, anybody who watches me at all knows I usually show their channel here. This is actually a website. Okay, this isn't really a YouTube channel, but this is spaceweather.com. And what this is again, they're going to explain to you guys things that I just did probably, because we usually talk about similar things. Dr. Tony Phillips runs this channel. He's a physicist, and I've never talked to Dr. Tony Phillips, but I know that the information that he puts out over here has proven to be correct more times than it hasn't. Okay, I can tell you that for sure. He's talking about the big bright cloud on Mars. I'm not going to get into that tonight, guys. Okay, guys, go over here, go give him some love. Please come over here and check him out. Here is I think that's, was that, nope, that was Noah. I'm gonna put this one in here. Copy, paste. Okay, so there you go. There's spaceweather.com. Go check them out. They do a lot of good work over here. They're showing the sunspots I just did. Here they are up here. Something else they do over here, guys, they'll give you a 24-hour and a 6-hour max of the flare level. That's a good quick reference if you just wanted something quick to look at. You can come down through here. This is near-Earth objects, okay? Asteroids, meteorites. You know, when you look over here and it says 2022 on the asteroid number, that means that's when it was discovered. So most of the stuff that's on this list, a lot of it is they just discovered it, you know, a day or two ago or a week or two. Sometimes they don't discover it until it's already past us and moving on by. So, and they measure it in lunar distance, the distance between us and the moon. They consider 16.7 LD, which is, if you went to the moon 16.7 times that distance out in a straight line, that's how far away that meteorite was. They call that near Earth. Okay, I chuckle at that, but it's true though. If you think about the whole aspect of space, that's why they say it's near Earth. Okay, to me and you, that's a lot of miles. Okay, but again, we're talking about the vastness of space. So but let's something else before we get off here. They do show noctilucent clouds here too. Now, if you guys don't know what noctilucent clouds are, it's water vapor that freezes around meteor dust that hangs around our poles, and it produces like a blue metallic looking cloud. Okay, why do we keep track of these things? Well, they happen in the summertime in each hemisphere, and the reason why is because when it's summertime, the water and the ice and stuff, actually you get ice melt, things are a little bit hotter, so you get a lot more vapor, right? Well, when that vapor gets high up in the atmosphere is always cold, guys. Okay, so without that water vapor, that's why because when you say something is being produced by ice forming around meteor dust, your mind is not going to go to heat or summer, right? Your mind's going to go to winter. So you would think that this stuff would happen in the winter. It's not the case. It's opposite of that because it's always cold high up in the atmosphere. So when you give it vapor, it freezes around that dust when it gets up so high. So it benefits us to pay attention to where these noctilucent clouds show up, because it will show you high up in the atmosphere basically how the climate and everything is actually up there, how cold it is, and there's a whole lot of things you can look at. But when you start seeing them inch up towards the equator, you know that things are a little bit different than what they were. And we've seen that, and they go back down, but they only happen in the summertime in each hemisphere. So right now, the southern hemisphere will be getting noctilucent clouds here in a few weeks. It's pretty predictable, okay? Just so you know. We can actually forecast them really, really well. Now, when we see them again here, I'll show them to you again once they start showing up. Anybody that's been with me here for any length of time, you would know that on this particular model, it shows up in like a really brilliant light blue in your face type of thing. So, but I'll explain it again once we start looking at that stuff again. Okay. But yeah. Also, he reports on fireball reports too. Okay. That 18 fireballs reported. And we are in the meteor shower. Actually, I think we're coming out of it, if I'm correct. One thing I can show you guys before we pop off here, I'm going to hang around just for a second because I didn't show you guys that again. There's been a lot of people talking about this, okay? Now, I know that's probably going to shock people. Don't freak out, first off. That's one of those sun diving comments I was telling you about. And this one here, it instigated an eruption on the sun. Watch. See how it started to do that right there on the end? And I'll show it to you here. Hold on. We'll pause it. We'll take it frame by frame. See how it's behind the culture disc? We can't see it, so it's probably over here somewhere. Look what happened. You guys see that? That's a bit of an eruption. And if you were to go look, it did. It actually instigated the sun. It excited the sun just a little bit. It wasn't nothing huge, but that did cause a little bit of an excitement there on that part of the sun. Okay, and you can go back and you can go look. Now, there's been a lot of these. Okay, because it's the Kritz meteor shower is what we've been going through here on Earth, but because of the line that we're looking at, we're able to catch these, right? So if I start that, tell you what, let's go back a day. This is back on the 8th. Nothing there. Back on the 7th, there's another one. There's actually two of them. Okay, there's one. And then there's one. So, I mean, there was two of them there. There was a small one back there. It just flashed. But anyway, we've had quite a few of them. So, just so you know. It's not showing the large white thing shot out right after it hit. Oh, yeah, I went to the next, I went back another day. Sorry, terrible. But yeah, it did. It definitely did instigate a little bit of an eruption here. I'll show it to you here again. Here it comes. And let's go to the next day. We'll look at the 10th. Might be able to see it right at the beginning. Yeah, you see that? That's the same spot. Okay? So that's exactly what happened there. So yeah. But anyway, guys, I am going to go ahead and end it here. It's getting kind of long here. I don't want to go too much longer. We've been here about an hour. So, guys, this is the Lifeboat. You guys know that this is my second channel with Captain Tommy. We do addiction recovery. And we're helping a lot of people, guys. If you guys know anybody in addiction, or if you yourself are fighting addiction, come over here. We can help get you guys some help. You don't get judged over here. You guys just rush on over here, and if you're drunk, if you're high, we don't care. Come on in. We'll talk to you. We try to help people, guys. Okay? That's just what we do. So if you just want to learn, come over here and check it out. But you guys would be doing me a favor if you guys came over here and just checked this out. And give it a subscription, leave a like on the video or whatever. We do live streams at 8 o'clock Friday through Tuesday, Eastern time. Okay, for an hour. And we talk about, well, right here. Why are we being judged and bullied and called names? Is it the drugs, or is it us and them? Those are things that we talk about. We talk about the fentanyl crisis, overdoses. I mean, it's rainbow pills that look like Skittles that are getting in. I mean, people are dying, and our kids. So if you guys are having problems with that, or if you just want to learn, please come over here. Check us out. It'd be doing me a big favor. So anyway, guys, God bless. Go check out Marfugal too, guys. I was over there, and then his something happened to his live stream right at the end. I'm going to have to go figure that out, what happened over there. But yeah, go check him out. And anybody else that I always say, Ripper, Trinity, Ilea over on Survival Game, everybody, guys. I wish I could just say them all, but I'll forget somebody. It's not intentional, guys. So anyway, guys, God bless. Yahushua saves, and you can drink this Kool-Aid.